everyone. So let's solve this LeetCode medium problem. Count Bowl Subarrays. So the problem states that we are given an integer array nums which has all means distinct elements. Now a subarray of nums is called a bowl if the subarray has a length of at least 3 and the minimum of its two ends means the nums of L and the nums of R. The minimum of those two values is greater than the maximum of all the elements which are lying in between both of these two values. Hence, if L and R are the endpoints of that particular subarray, then the minimum of those two values is greater than the maximum of all the values which are lying in between. And if this condition is satisfied, then that particular subarray is called a bowl subarray. Now, out of all possible subarrays that exist for this nums, we need to return the total number of bowl subarrays in this particular nums. As we can see, like nums can go up to 105 and nums can only consist of distinct elements here. So let's see the given input first. So we have the input as 25314. So we see like we can try iterating through different subarrays. So if we see the bowl subarrays are 3, 1 and 4, because for 3, 1 and 4 this minimum of 3, 4 will be 3 and which will be greater than the max of inner elements which is 1. Okay, so hence this 3, 4 is greater than max of 1 which is 1. So hence this is a bowl subarray. Similarly, this is also a bowl subarray because the max in between is 3 only and the minimum that we have is 4 and 4 is greater than 3, hence this is also a bowl subarray. Similarly, for other inputs, we will be able to see, like if we try to iterate through all subarrays, we will be able to get the different outputs here. And for this input, we see like the only 3 length subarray is this only, and we see the max of this will be this value, which is means the minimum of this is this value and the max that we have is this value. So this minimum is not greater than this max, hence the output here is 0 only. So what can be the most naive way of solving it? It will be simply like iterating through all the subarrays of nums and see like whether it satisfies the condition of being a bowl or not. So we'll simply like iterate through all the possible subarrays. Like we'll move this L from 0 till since we need all subarrays greater than or equals to 3. So this means the starting point will be from n-1, n-2, n-3. So we can move L from 0 till n-3 because means the valid starting point will be at most the maximum right can be n-3 only. And now the endpoints can go from like L plus 2 till n-1. Now the subarray that we have L to R will simply find the maximum in the range L plus 1 till R-1 and we'll see whether the minimum of nums of L comma nums of R is greater than the max in the range, which is max in the range. Okay, if it is thus, then we'll simply increase our count by 1. So hence we can do this manner. Now either we can calculate this maximum by reiterating through the subarray. So it will again take a big of n and this is already taking a big of n square, or like we can avoid this calculation at every step by like pre-computing, means computing this maximum in the range in like a running form. So what you can do is, currently if L suppose and R we have, so R will start from L plus 2. So the inner max that we will have initially, it will be simply nums of L plus 1 only. Now for this means the L to R that we will have, this inner max will be 2. Now if you want to move this R further, then for this R it will be means this inner max will get updated by max of like the inner max initially that we have or nums of R, right? And then we'll be able to like when this R becomes L plus 3, we'll have the inner max as max of n plus 1 as well as n plus 2, which was R initially. Since we can follow this and we'll be able to like compute this prefix max, means range max in big of n, means big of instead of big of n we'll be able to do it in big of 1, and hence the overall complexity will be big of n square. And let's see the code as well to get the proper understanding. So we initialize the count with initially as 0. Now we iterate through all the starting points as well as the end points. This current inner max that we have is nums of L plus 1 because the end point is starting at L plus 2. Now we see like whether the minimum of nums of L and nums of R is greater than this current inner max that we have. If it is, then we'll simply increase the count. Now we need to increase, means update this current inner max, because now this R that we had will move from L plus 2 to L plus 3, right? So this L plus 1 and L plus 2 will become the part of inner max, and we'll have L here and R here. So we need to update this max with what? The max of current inner max that we have and the nums of R. So we'll keep doing this at each step, and we'll simply return the count in the end. And as we can see, like the time complexity is here is of the order of n square only, and since n can go up to 1e5, so this will give us TLE here. So hence we need to optimize this approach to something of the order of n or something of the order of n log n. So now how do we move towards the optimization? So we see, like if we have a range L to R, okay, and we need to satisfy the condition that minimum of L comma R is greater than max in the range L plus 1 till R minus 1. So that means that we need to find the element such that this means, since minimum of the both these values is greater, that means nums of L will also be greater than max of L plus 1 till R minus 1, as well as nums of R will also be greater than max of L plus 1 till R minus 1. Okay, so means both of these values will be greater than the maximum that we have inside. Okay, so hence what do we need to do here? Means we need to find, means, and this max from L plus 1 till R minus 1 will be like a constant value. Suppose we need to find, means if we are at a particular index I, what do we need to find? We need to find some index on the left which is greater than this value, and first index on the right which is greater than this value. Means, okay, since we need to find nums of L which is like greater than nums of I, as well as this nums of R is also greater than nums of I. Okay, now you see, like if we check for I plus 1 and condition for I was satisfied. Okay, so the new means left max that we'll get will be either if this becomes the new max of this new range, means if nums of I plus 1 is greater than nums of I, then that means this will be the new max, and then this L will either shift backwards or remain here only, and this R will either shift forward or remain here only. So this means like L will decrease and R will increase maybe. But if this nums of I plus 1 is less than nums of I, that means it is smaller, means this value nums of I plus 1 is smaller. So for this I plus 1, the means the L will be here only. Okay, and then R may be decreased. So L will remain same and R may decrease. Okay, so hence we see like for each element, for each I, only one possible means a Bowl Subarray is possible. Bowl Subarray possible with nums of I as max. Okay, so this is the observation that we can make from this. Like for this particular I, if this is a particular max of this range, then there can be only a single subarray which will satisfy the condition of LR, such that nums of I, means the maximum that we have, this minimum of L comma R is greater than nums of I. Okay, so hence what we can do is we can iterate through all the i's from 0 till n minus 1, then find the first max on left, then first max on right, and means first max on left and first max on right means both are greater than nums of I. And if we have means both of these conditions satisfied, then we will simply increase our count by 1. Okay, so why we are able to do this? Because it was explicitly mentioned that nums can only have distinct elements. Okay, and since nums can only have distinct elements, hence we can see like there will not be a case like I and I plus 1 both will give the same LNR. Okay, so both will give the same LNR, hence there can be multiple subarrays for the same LNR. Okay, so hence from that we observed like for a particular I there can only be a single Bowl Subarray which has the max as that particular nums of I. Okay, so we can do that. And now finding about the max on left, whether there exists a prefix, means whether there exists a max from 0 till I minus 1 such that nums of, means whether there exists a L in 0 to I minus 1 such that nums of L is greater than nums of I. We need to find this, as well as from I plus 1 till n minus 1, we need to see whether there exists any number such that nums of r is greater than nums of I. Okay, so what you can do here, since we need to just check whether there exists this nums of L or not, so what we'll do, we'll simply create a prefix max. Okay, prefix max means the maximum element that we have in this range, and we also can create a suffix max, means the maximum element that we can have in this range. Now what we'll do is, we'll simply see that the maximum element that we have till now, whether that maximum element is greater than nums of I, as well as the maximum element that we have on the right, whether that max element is greater than nums of I. And if both of these conditions are satisfied, then we'll simply increase our count and we'll be able to do, means solve this problem in the order of n. Okay, so just these two pre-computations we need to do, and then we are able to transition from the brute force approach that we had to this approach. And why, means how did we transition? We try to observe for each particular I, how many subarrays can it contribute to, and then if we try to see this formula, we saw that it can only have a single Bowl subarray which has nums of I as maximum, and that Bowl subarray may also not be satisfied. So hence we need to see the maximum element on the left as well as the maximum element on the right, and see whether both of them are greater than nums of I or not. And if both of them are, then we'll simply increase the count, and hence we'll be able to solve it in big of n time complexity as well as big of n space. So let's see the code as well, so that we are crystal clear on the implementation. So we are given that n can be, means n can be greater than or equals to 3, we are already given. So we simply do not need this condition here. Okay, now we create this prefix max. We will be storing the maximum element in the prefix 0 till I. Okay, so prefix of max of 0 will be simply nums of 0. Now we iterate from 1 till n minus 1, and at each step will be updating prefix of max of I will be prefix, means the maximum that we had till 0 till I minus 1, and the element that we have at ith index. Okay, so we'll updating prefix of I minus 1 and nums of I. Okay, so we'll simply update the prefix of I with maximum of these two values. Similarly, for the suffix max as well, we'll iterate from the end, and we'll see update our suffix max with the maximum of the suffix max that we have got from I plus 1 till n minus 1, and the value that is present at I. Okay, so we'll update it with max of both of these values, and suffix max will also be updated. Now comes a part where we'll iterate through I, and at each step we'll find the left max and the right max and see whether both of them are equal or not. So we'll iterate for I, because instead of iterating from 0 till n minus 1, we see for 0 there will be no element on the left, and because we need subarrays only which have a length greater than or equals to 3, hence we'll simply iterate from 1 till n minus 2, so that means some elements on the left as well as some elements on the right exists. Now we see whether if we have a left wall, so we'll see that prefix max till I minus 1 should be greater than nums of I, as well as suffix max from I plus 1 to n minus 1 should be greater than nums of I. And if both of them are true, then only we'll be simply increasing our Bowl count, and in the end we'll return this Bowl count. So this was the order of order of n approach. Let's try to submit the code as well and see how it works. So this is the same implementation that we talked about previously. Let's and as we can see, it runs in 8 ms, which is fair enough because n can go up to 1e5, so it is very fast. And now let's try to see, means okay, and we also saw the brute force solution that it took big of n square, hence this will be giving us tail. So this was the overall approach for this problem. I hope you were able to see how a particular nums of I is only a part of a single Bowl subarray, and once we identified that, and this was the key observation here, that it only consists of distinct elements, then means it was easy to transition from the brute force to the the optimized one. So I hope you were able to follow along, and if you did, make sure to like as well as subscribe, and if you have any doubts remaining, feel free to comment down and I will be happy to help. Thank you so much for watching.